I'm back at my workbench tonight to do some updates to my fruit tree moisture sensing project. In the last video, I wired a particle photon microcontroller to a moisture probe and wrote the software needed to have it measure the voltage across the two probe pins inserted into the pot to decide if it needed to be watered, and if so, email me. The setup works, but one issue I noticed was that after taking several readings, the value would start to increase incorrectly. This problem appears to be caused by a buildup of noise on the input line and can be resolved by allowing the noise to discharge to ground by splicing off of the input side and connecting a resistor to ground. In the previous video, I used a moisture probe that I had purchased to wire up my orange tree. Now I want to also wire up my lemon tree, and to do that I will build the probe from scratch using 2 galvanized nails. This method works because the particle photon has built-in analog pins to directly read the signal from the wire. If instead I was using something like a Raspberry Pi, which only has digital I/O pins, I would need to use an analog to digital converter. Once I wire up the lemon tree, then all I will need to do is update the code to handle reading from both trees.
In the first version of this project, I used a purchased moisture probe to insert into the soil. That purchased probe can be easily replaced by instead wrapping that end of the wire around a galvanized nail. Then both nails can be inserted into the soil. The key to eliminating noise on the input line is to modify my original design by adding a path to ground through a resistor into the input line. Now have the wiring for a DIY moisture probe with 2 galvanized nails at one end that will go into the soil. At the other end, I have 3 leads. The green lead will go to the power pin and the blue lead will go on the analog input pin. The white lead is spliced into the blue input lead with a resistor and is connected to ground. This will clean up any noise on the input line and allow random voltage to discharge to ground when the input pin is not enabled. Next up is to design and print a spacer to separate the 2 nails. I am using my 3D printer for this, but it can be made from anything that does not conduct electricity and that doesn't deteriorate with moisture. Finally, I use my soldering iron to heat up the nails so that I can slide them into the spacer. The core change to the code is the implementation of a two-dimensional array to store our probe information. I have 2 rows here for the first dimension of the array that represents each probe, and if I ever add a third probe to measure, I can just expand this dimension of the array. I have neatly defined indexes 0 through 4 of the second dimension of the array so that I can cleanly reference the power pin, input pin, threshold, value, and timestamp of each probe. The next change to the code is modifying the setup function to iterate through each of the power pins for each probe to set that as an output pin. After that, there is a change to the getReadings function to loop through each probe and call the getReading method, passing in the index of that probe and setting the sensor value in the array. In the getReadings method, we simply modify the code to use the index and the array to read the correct pins for the probe we've decided to check. Finally, in the checkThreshold method, we loop through each probe in the array, comparing the proper sensor value to the probe's threshold value. We then check the timestamp for that probe, and if it meets the requirements, we use the probe index into the message array to get the messaged email for that probe and append the reading. That now completes the modifications needed to handle multiple probes in the code.
Now that both my lemon tree and orange tree are wired up, they can email me whenever they need a drink. And I don't have to worry about forgetting to water them. I really enjoyed working on this small electronics project, and I hope you enjoyed following along. If you would like more information on the products I used, feel free to check out the links in the description below. And if you have questions, feel free to put them in the comments below. If you found this project interesting, feel free to click the like button. If you want to follow along with my future projects, feel free to hit the subscribe button, and I'll see you on the next video.